The apply function and its variants are useful for applying a function across an R object. We'll consider two variants of these special class of functions, apply and tapply, and we'll also look at the by function. I'm going to start by loading in a new dataset, website revenue for the month of March for 10 businesses. I've used the argument header equals false because there are no column names stored in this comma-separated values file. The data in this data matrix have been stored in a slightly unorthodox way. Each business is represented as a column, and each row represents a day in order of March 1st through March 31st. So, for example, on March 3rd, the 10th business made $23.98. It might be helpful for me to take a quick look at how the businesses are doing by taking a look at their total revenue. I could take the sum for each column using a for loop and store that result in a vector, but this would actually be inefficient. Instead, I should use the apply function, which will be more compact and also run faster with larger datasets. The apply function is useful for applying a function across either the rows or columns of a data matrix. That is, I might want to apply a function across each row separately or across each column separately. The first argument is the data matrix itself. The second argument is the dimension number over which to apply the function. Rows are represented by number 1 and columns by number 2. Think of the second argument as specifying the dimension that you actually want to retain. The last argument is the function to be applied. In a similar way, we can also compute the total revenue for all the companies on each day of the month by applying the sum function over each of the rows. Notice that there are some missing observations. If we would look into the data more carefully, we would find that there are two missing values, each in the third column. If we know that it's okay to omit these data, we can tell the sum function to ignore the missing observations using na_remove equals true. The apply function passes this argument onto the sum function. Generally, any extra arguments to apply will be passed to the function you specify in the third argument. In this particular use case, we probably should want to investigate the missing observations rather than simply ignore them. Also, just a technical note, for this application of apply, I could have used either the callSums or rowSums functions. Alright, onwards to the second function, tapply. To help explain this new function, I'm going to load in a second dataset that summarizes eBay auctions for the Mario Kart video game for the Wii. This is a tab-delimited text file of the data, so I'm going to read it in using read_delim. To keep things simple, let's focus on three variables: wheels, conditions, and total price. The tapply function is similar to the apply function in that it helps aggregate data efficiently. For instance, we could examine the sum of all of the total prices of auctions that were new and used separately by providing the vector for the total price as the first argument, the vector for the conditions as the second, and then the sum function as the third. Just like in apply, the third argument for the tapply function is another function to be applied across the data. However, in this case, the function is applied to each group, where the groups are specified by the second argument, which in this case is the condition of the game. I'm going to modify this command a little bit since it makes more sense to look at the average price of the game. As you might have anticipated, the games that are new tend to sell for more than the games that are used. Here, the difference is about $10. There's a second important variable in this application that relates to the price: the number of steering wheels that come with the game in the auction. These steering wheels are a game accessory that make playing Mario Kart a bit more fun. Let's look at the average price of the auctions with different numbers of wheels included. As you might expect, we again see a steady increase in price associated with having more wheels included in the auction, about $6 to $10 per wheel. Now, there's something interesting to think about here. If I consider the influence of both price and the number of wheels simultaneously, what will this do to the estimated cost of a new game versus a used game, and also the cost of an extra wheel? A table to look at the average price across each of the combinations of condition and wheels can be made using the tapply function. To do this, I'm going to provide the data frame with just the condition and the wheels columns as the second argument. Some of these numbers look a little bit surprising. For instance, going from no wheels to one wheel doesn't seem to influence the price when the game is new. If we dig in a little more, Here, using the length function in place of the mean function, I can see that one of the groups had very few observations, and so this average is probably less reliable, and this might explain the difference. If I was going to continue this analysis, I'd probably look into this some more. One last function before we wrap up. The by function is a variant of the tapply function, but by default, it returns a vector of the results. Note that when it is printed, it won't really look like a vector, though you could access the elements just as if it was a vector. In the next video, we'll take a look at three functions: with, within, and aggregate.